Hi everyone, I hope you are doing good. So today in this C++ advanced series, we will cover the C++ structured binding, and we will cover all aspects and scenarios of the structured binding, and we will understand that. So let me tell you what we will cover in this video. So in this video, we will cover the introduction of the structured binding with example, and then we will cover the supported types. What are the types where we can use the structured binding, like tuples, pairs, arrays, structs. Each and every types we will cover with the example, right? And then we will see the usage of the advanced usage of the structured binding, like structured binding with loops, right? Range based loops we will cover, structured binding by reference, by value, that we will see, and in conditional statements like if statements, if else statements, switch statements, we will use the structured binding. So these also we will cover with the live code examples, and then at the end we will see the limitations and best practices of the structured binding. So please watch the video till end so that you get the clear understanding of the structured binding and you can answer any interview questions in the interview. So let's start with the introduction of the structured binding. So this topic, structured binding, got introduced in C++ 17, and since then we are using it. And the main purpose of this structured binding, as by name says, binding, right? So it binds the aggregate, the members of the aggregate type into the individual variables, or in other words you can say, basically it allows unpacking of the aggregate objects into the individual variables, right? You can say we have, for example, we have one aggregate object, right? And that contains member 1, member 2, member 3. So this is the single object. Now this aggregate type, right? So now if we want to unpack this one, and we want to take these members into the individual variables, right? So for example, v1, v2, v3. So we have these three individual variables, correct? So if we want to bind these two, m1, v2, right? So this is like this, v1 is binding to m1, v2 is binding to m2, and v3 is binding to m3. So this is how we are, what we are doing here, we are unpacking. This is packed version of the aggregate type, right, which contains m1, m2, m3. Now we are unpacking this, so this is called the basically structured binding, right? Structured like object, we, that is what we are unpacking, right? So this is kind of structured like object, you can say, and we are trying to unpack this one. So this is called structured binding, right? And this improves the code readability and conciseness. And the syntax of this structured binding is how we use, for example, we have a array, right? ARR, right? You can say integer array of 2 element, right? That is 1, 2. You can say these are the values. So now how can we unpack this array into the individual variables? So for structured binding, we have to use auto keyword, right? Auto keyword. Then we have to use bracket, and here we have to give the variable names v1, v2, right? And then we have to basically initialize this one with the ARR, right? Or structured like object, that is ARR. So this is how, this is the syntax of the structured binding, right? This is the structured like object, you can say, or aggregate type, you can say, whatever, right? Or tuple like object, you can say, right? So this is what we have to unpack, and this is how we unpack the this structured like object, right? So this ARR, this is having this two elements, right? You can say ARR 0 and ARR 1, right? So these two values will be mapped to the, will be copied basically to the v1 and v2 if we do like this one. and by reference the other variant of this structured binding is we can do by reference as well. So in that case, what we use, what is the syntax is auto, right, and we use ampersand here, this, right, and then same thing v1 and v2, and here arr, correct. So here this ampersand we have to use. If we are using ampersand, in that case, uh, like the copy does not get created here. This v1 will directly bind is the new name or is the reference of the arr0, and v2 is the reference of the arr1. That is what happens behind that, right. This v1 will go to is the reference of the arr0, and this v2 is the reference of the arr1, correct, in case of the reference. And in case of the value, by value here in the upper syntax, this one, right. So here this get copied to the v1 and arr1 get copied to the v2, right. This get copied to the v1 and this get copied to the v2 here, and here these are the reference, correct. I hope you are clear with this one. We will also see with the examples here in the upcoming slides. So I hope till now this is clear, right. What is the structured binding? Structured binding is a way of unpacking the structured like objects, right, or aggregate types, or you can say tuple like objects into the individual variables, right. We have a complex object which may be having multiple members, right. uh, as you know, structured classes, arrays, tuples, right, pairs have only two, right. So these objects can have the multiple members, and if we want to unpack these members into the individual variables, then we can use the structured binding right uh, feature of the C++17, correct. So I hope it is clear now. Now let's move on and see the simple example. So this is the array example, right, which we have just seen. So here we have the array of integer, right. Two integers array, right, arr0, arr1, and we are using the here by value we are doing, right, structured binding by value. So here arr0, so here what will happen, this x will have the copy, this is copy of arr0, and y will have the copy of arr1, this is copy, right. So now if I make any change to x, then that will not affect to arr0, and if I make any change to y, then that will also not affect to arr1. Or after copying here, after this line, if I make any change to arr0 or arr1, that will also does not affect to x or y, correct, because here x and y will have the separate copy of the arr0 and arr1. I hope it is clear, right? And the syntax is already clear in the last, right? I have already explained the syntax. Auto keyword we have to use. Here we cannot give the exact type, right? And that is why not, that I will also explain in the upcoming slides, so don't worry about that. But you have to make sure we cannot use any exact type here. Like if you want to, if you can say, yeah, we know the type of array, right, array, and all members of the array will be integer, so why can't we use int here instead of the auto, right. So that I will also explain in the upcoming slides, so don't worry about that. But you have to keep in mind we can use only auto keyword here, right, nothing else. And in bracket we have to give the or member variables, sorry, or newly created names of the variables, right. And then here right side we have to give the structure like object or the aggregate type. That is what we have to unpack, correct. I hope it is clear now. So now we will see the supported types of the structured bindings. What are the types where we can use the structured binding, right. So here the first type is array, that is what we have already seen, right. Normal array, C style array, we have created two array of two integers, right, and we have unpacked them into the x and y. That is what we have already seen. Tuples, pairs, we can use the structured binding, std array, with std array also we can use the structured binding, right? I hope you know about tuples, pairs and arrays, right? And structs and classes. So there also we can use the structured binding, but the condition for the classes and structs are like all the members must be public, right? And yeah, all the members must be public, right? And if in case of classes or structs, if it is following the inheritance, in that case all the members, public members from the must be from one class. Either it should be from base class or it should be from the child class, else uh, else it will not work with the structure binding. That is what the limitations with the classes and structs that you have to keep in mind, correct? So we will see one by one. Array we have already seen, so we will see tuples, pair, array, structs and classes with the examples in the upcoming slides. In meanwhile, if you have any query, doubts, you can comment below the video. I will try to reply there itself, right? So structure binding with tuple here. So you know the tuple properties, how to declare or define the tuple here, right? So this is the way we have to use the std tuple here, right? And for this we the tuple of two members basically here. It can have multiple members, right? Right, three also, right? Like tuple, int, double, then int, and so on. Like this we can basically declare, define the tuple, right? Here in this case, in this example, we have only two members here, right? So here we have integer and double, and the values of the integer is 1 and value of double is 2.5, correct? And the variable of tuple is t, right? This is the object of the tuple, right? So now we have to basically unpack this tuple, right? This tuple is having integer and double, and we have to unpack this into the individual variables. So how can we do that? So we can use the structured binding here, right? Auto keyword, that is what we have already discussed. New variables x and y, and then we are assigning this structure binding to the auto, right? Basically this t is assigned to this auto x and y, correct? So now this the compiler, what will do, it will basically unpack this structure like object, this aggregate type tuple object, into the individual variables x and y, right? So now x will have the copy of the this t0, right? And y will have the copy of the t1, correct? Copy. Here we are not using any reference, right? That is why we are not using reference. That is why the copy will get created. If we will use reference, then the copy will not get created. The variables, newly created variables, would be the reference of the existing basically member variables, correct? So I hope this is clear now, right? X is having 1, y is having 2.5, right? So I have created the examples also, C++ examples also. If you want those code, uh, right, then you can comment below the video. I will provide the C++ code as well there, right? I am thinking that I am also explaining in detail, so no need of showing here that code. If you want, I can provide that code as well, right? So let's check the another example here. So pair, right? So here in case of pair, right, std pair, this is how we declare, define the pair, right? Pair keyword, and then pair can only have two members, right? First and second only. In case of tuple, we have multiple members. It could be 3, 4, 5, right? Whatever you want, right? But in case of pair, we can have only two, right? This is the first and this is the second. That is how pair works, right? And this is the pair object we have created, and these are the values, right? So this pair contains the integer value, right? That is the type integer, and one string, right? This is the hello, that is the string, right? So now we want to take these two members of the pair into the individual variables, right? ID and name. So how can we do that? Right, we can use the structured binding. And other way is like p dot first, we can say like int, right? And sorry, we can say integer id equals to p dot first, and then here string name is equals to p dot second, right? So this is how this is the traditional way which can be used to copy basically the pair members, right, to the individual variables, right? But this is the traditional. In case of pair we have two only. In case of tuple we can have the multiples, 10 members or 100 members, right? Then we have to write the 100 lines, correct? So but if we use the structured binding, then we can resolve this we can combine all these statements into the single line, right, with the simple syntax, correct? So this is how we do. So now here what will happen? So now here with the structured binding, what will happen? So this p dot first, it will get copied to the id, right? Copy, right? And p dot second, this will get copied to the name, correct? Here, this one, id is having one, name is having hello. That is what happens, right? So I hope this pair case with the structured binding is also clear to you, correct? Let's check the next example here, std array, right? Array we have already seen, and this is similar to the array, only the syntax of the declaration of the std array is this one, right? We give the integer type, any type, and then the number of the members, right? How many, the size of the array basically, correct? So here we have 3, so 3 members are there, 10, 20 and 3. I have initialized this std array arr, and I am unpacking this arr to the a, to the b and to the c, right? A, B, C, correct? So A will contain the copy of the arr 0, and B will contain the copy of the arr 1, and C will contain the copy of the arr 2, correct? So this is what happens, right? You can try your own. It will create the copy. The ABC will have the copy of the arr 0, arr 1 and arr 2, correct? And now let me clear this one. So now the example with the structures, right? Structure and class are the similar cases. Here we, as I have already told you, we must have to keep in mind that the members should must be public for struct and the classes. By default for structure, the members are public by default. No need to use the access specifiers, right? If we are not using any access specifiers in the structure declaration, then the members of the structs would be public. But in case of the class, if we are not giving any access specifier, then the members of the class would be private, and there we cannot use the structure binding. If we want to use the structure binding in case of the class, right, then we have to use the here public access specifier, right? So that members of the class should be public here, and then only we can use the structure binding, correct? Here you can see. So I will explain only one here. So here in case of class we have created the point object, right? And this point object will have the, so you know, right, class is the blueprint, right? When we create the object, that is the object of that blueprint, right? That is the type, correct? You can say. So this pt, this is the object of the class, right? So you can say pt dot x, that is what, 5, and pt dot y, that is 10. That is what we are initializing here, correct? Now we are doing auto xy equals to pt. It means what we are doing, pt, we are unpacking this pt object, point object, to the x and y, right? So x will have the copy of the pt, right? It will have the copy of the pt, and y will have the copy of the point dot y, right? This one. So this is how it works, right? So here in this example we have only 2 members, but it could be the case where we have the 10 members, 100 members, right? Right. So there also it is very easy and like very simple to unpack this complex object into the individual variables, correct? So that is how this structure binding works with the class and structures. For structure also this is same, right? This is for the structure. I hope this is clear to you. Uh, Simple array, C style array, STD array, tuples, pairs, struct or class. I have explained each and every one, right? Now coming to the advanced usage of the structured binding are like we can use the reference qualifiers, reference and const keywords we can use with the structure binding. For reference, I have already explained you briefly, like we use the ampersand, right, after the auto keyword, right? After the auto keyword, what we use? Auto, and then we use ampersand, and then in bracket we give the variables, right? If we are using this auto, this ampersand here, it means we are taking this variables here, v1, v2, and so on, right? So these are the references of the original basically member variables, right? These are not the copy of the member variables. These are itself the reference of the original members. So basically that is what happens when we use the ampersand. I hope it is clear. We will also see the examples of the reference qualifiers and the const, right? And then this comes in the advanced usage of the structure binding. Now range based for loop. So here in range based for loop also we will try to use the structure binding, right? Because as you know, I have already explained you, we can use the structure binding with the simple array, STD array, tuple, pair, right? But for example, we have a vector of pair, right? But with vector we cannot use the structure binding. So there we will make use of the range based for loop, etc., right? So that also we will see in upcoming slides. And if and switch statements, so there also we will use in the initializer statement of the if or switch, right? Where we declare the condition, right? So there also we will use the structure binding, right? And then we will try to use the returned value from the function, right? There is a function, right, and that function is returning some pair, for example, and that pair we have to unpack that. Can we use that with the structured binding? Yes, we can use, right? So that also we will see in the upcoming slides, where one function will return some aggregate type, and that type directly we will take into the structured binding statement, and there we will unpack that directly, correct? And now maybe in your mind one doubt is coming. So we are using the structured binding for the returned value, so can we use the structured binding with the parameter list, right? So that question should arise, should come into your mind, right? So think about it, and my answer is like we cannot use the structure binding in the parameter list, right? Why? Because the compiler, the condition is at the compile time, the compiler should know, must know the type and the members of the that members are there, like how many members are there in the aggregate type, basically. That is why we cannot use the structure binding in the parameter list. I hope it is clear to you, right? So let's see one by one all the advanced usage of the structure binding with reference. So we have created one pair here, right? Pair, and that is a constant pair. P is having two members, right? 1 and 2 are the values. So now here, see here, this is the difference. We are using ampersand here, right? Earlier we were using only auto keyword, and then in bracket we were using x and y, and then we are giving the pair, right? So and here this is pair, that is why we are using const here, right? So we can omit this const also, right? Only we can use only auto, like this, auto ampersand x y and then p, this one, right? So here if we use this one, and then we can remove this constness. Const, I hope you know about the const, right? If we make any object const, it means we cannot make any, we cannot directly make any change to that object, right? Or if we are making any variable const, right, It means we are if we are using any if we are using const keyword for any variable, what does that mean? It means like that x, whatever the variable is constant, we cannot make any change to that variable. That is what with the const, right? It is I hope you know about this one, const, right? So I'm not covering const here. So this auto keyword with reference, that is what we will focus here with the reference, right? Structured binding with reference. So here P, right? And P is a pair, correct? Non-constant pair, right? So now here what will happen? So we will have the P dot first and P dot second, right? And now we will have the X here. So X is the reference of the P1, P dot first, and Y is the reference of the P dot second, right? This is the ref, right? X and Y are not the copy of the P dot first and P dot second. These are the reference. P dot first, this is basically the new name of the P dot first, and Y is the new name of the P dot second. That is what happens when we use the ampersand, right? So you can make use if your requirement is like this, and when you know, I hope you know that when we have a reference of any variables, right? It means these are the new names of that variable itself. So here also, if you make any change to P dot first, right, after this line, so that will also reflect to the X, and P dot second, if you make any change to P dot second, then that will also affect to the Y, or vice versa. If you make any change to X or Y, then that will also reflect to the P dot first and P dot second. Why? Because these are the references of the original member variables. I hope this is clear to you. I have examples of this one also that I will show you at the end. So and if you want the code, then you can comment below the video. I will provide the C++ code as well for all these, whatever the examples I have taken here in the slides, right? So let's see the next usage of the advanced C++ structure bindings, right? So this is the range based for loop, right? So here I have already told you that the vector is not supported with the structure binding, correct? But the vector of pair, so pairs are supported, right? So how can we make use of the structure binding here? So what we can do here, we can take the range based for loop. I hope you know the range based for loop, right? Here, so here what will happen? This vector is the this VC, this is the vector variable, right? Vector of pair, right? This is the type of pair, right? Whatever we are giving here. So this is the vector of pair, correct? So now here this vector, so in range based for loop, what happens? It starts from the beginning of the vector and it goes to the end of the vector, right? In each and every element of that vector, it will copy pass to the left hand side expression basically here, correct? So for example, in simple case, let's take a vector of integer, right, v, and it is having, for example, 1 2 3 three variables, right? And if I want to try the range based for loop here, then for loop for integer x and then v here, right? And this is the for loop, and see out x, this one, right? So now this vector is having 1 2 3, correct? Now what will happen? This integer x, so x will contain the first variable, right? First what will happen? So from here vector, we will the one will get copied to x, right? One will get copied to x, correct? And then x we will print here 1. And then in this next iteration, what will happen? The second element, it will get copied to x, right? Again the second element will get copied to x, so that is 2. So then 2 will get printed here, correct? And then in the third iteration, what will happen? This 3 will get copied to the x again, correct, in the same variable x, and then 3 will get copied here, printed here, right? And then we are here out of this one, because we have only 3 members, so in the 3 iteration we are done with it. So now it will automatically come out from the for loop. That is the range based for loop. It means the range of this for loop is beginning of this v to the end of this v vector. Correct? I hope it is clear. Right? Now you can easily understand the given example here. Right? So this is the vector. So here we have two elements. Correct? So that is why we are giving here a and b. Right? So the first element, this one, this will get copied to this one. So this is kind of this one, right? Auto, then a comma b equals to this member, right? It means v vector of 0, that is 1 comma 2, this one. And again in the second iteration, what will happen? A comma b, and here 3 comma 4, this one. Correct? This is how the expansion of this this expression basically here. Correct? So the first element will go first in the first iteration, and then again we will go for the second iteration. Then the second element of the vector will go to the assigned to the this left side, right? Whatever here, right? And now here the structured binding will get applied, right? Here now the 1 will get copied to A, and this 2 will get copied to B, right? This is in the first iteration, right? First iteration. And this is the second iteration. Here there 3 will get copied to A and 4 will get copied to B again, right? So here first this 1 and 2 will get printed, and then in the second iteration again it will go here, and then 3 and 4 will get copied to A and B, and here 3 and 4 will get printed. I hope it is clear. This is quite confusing, but yeah, it is very simple. If you know the range based for loop, then it is very simple for you, right? I hope it is clear to you. So let's check the if statements with the structured binding here. So this is the same case for the switch case also, right? So here just try to understand. Here we are using the map, std map, right? A map of integer and string, and we are creating the m object. And here we are having this map is having only one key value pair, right? This is the key, and this is the key, and this is the value, right? So key value pair we are having only, right? Correct? So now what we are doing here, and I hope you know about the insertion operations on the map, right? This is the inbuilt functions of the map insert, and what it does basically, it takes the pair of the key value, right? Key value pair it will take, and it will try to insert it into the map, right? If the key is already there in the map, in that case it fails, right? And it fails and it returns a pair. It returns a pair of basically the position here, this one, right? And the status. Correct? So it will return the pair of position and the status, right? And if it fails, it means the key is already there in the map. Correct? That pair with that same key is already there in the map. So it will return the old position. It will return the old position, right? Correct? And the status would be false, right? Old position, right? The already inserted the key, right? Already inserted key position, and it will return the false status. It means insertion operation failed. Correct? And if it is passed, then the new position it will return, and the status would be true. That is what happens with the insertion operation. Correct? I hope it is clear. Till now it is clear. Now what we are doing here, so we are having here position either old or new, right? Position we are having, and here in success we are having the true or false, right? And why? Because this is here we are using, here we will have the map, right? And that map will be basically unpacked to IT and success. And the success variable, newly created success variable, right? Unpacked variable, that is what we are using in the condition here in the if. Right? I hope it is clear. This is little bit complex example, but this is very simple. Here what we are doing, this insert operation will return one pair. That pair will get unpacked into the IT and success variables, right? And its success variable, that is what we are using in the condition for the if statement, right? I hope it is it is now clear to you, right? And the insertion, the return type of insertion is a pair of the position and the status of the operation, right? The usage of the structure binding with the return value from the function, right? So here you can see I have created one function fun, and the return type of function is a pair of int and int, right? And it is returning a pair here, correct? This is very simple, right? Till now here we are using the return value, this is the right side, right, of the expression, and here we are calling and we are taking this return value into the this expression of the structure binding here, right, directly, correct? So now what will happen, this is similarly the case of the pair, right, where, so because what will happen, once this function is executed and it returns the value, then instead of this function what will be the value here, this is would be 10 and 20, right? And this 10 will get copied to the v1 and this 20 will get copied to the v2, correct? I hope it is clear. This is very simple if you know the mechanism of the function call, correct? So let me explain it again. So here we have a function, return type is a pair, std pair, right, of int and int, and we are returning a pair here, right? When we call it from here, then this call will go to here and it will return the pair, right? So what will happen, so this is similarly you can see you can say this is auto, right, v1 v2 equals to 10 and 20, correct? And now this 10 will get copied to v1, right, because we are not using any ampersand here, we are using the structured binding by value only, right, simple expression, and this 20 will get copied to the v2, correct? I hope this v1 will have the 10 and this v2 will have the 20. I hope this is clear, right? If you want the code examples, C++ code, then please comment below the video. I will provide the C++ code as well. These are the advanced usage of the structured binding, right? Now coming to the limitations of the structured binding. So the first limitation is we cannot use with dynamic containers like vectors, sets, or map, std map, right? So these are the dynamic containers. So there we cannot use the structured binding, but we can make use of the these dynamic containers, right? For example, we just have seen the example of the range based for loop. There we have used the vector of pair, right? So we have used the structure binding there, right, for pairs, right, correct? So that is how we can make use, but this is the limitation, we cannot use the structure binding with the dynamic containers like vector, set, right, map, etc. Not allowed directly in the function parameter list. That is what I have mentioned earlier also. This structure binding does not allow with the parameters. Why? Because in function, for example, in function we can use auto, this v1 v2, right, like this. But now here the condition for this one is this must be initialized, right? This expression must be initialized, right? So but this is not initialized, right? When the function will get called, then only this will get initialized, right? And that will happen at the runtime, right? But the condition for structure binding is at the compile time, compiler must know the type of the v1 and v2 and the number of parameters, right? One more limitation you will see there, like the partial binding will not allowed. See here, partial binding is not allowed, right? So here at the time of the compilation, we do not know, the compiler does not know how many parameters will be there, how many members will be there in the aggregate type, and what are the types of those members. That is why this is not allowed in the parameter list, correct? So now coming to the third, only works with public members of the aggregate types. I have already mentioned this one in the when we were seeing the example of the class and structs. Why for public only? Because the private members are not accessible outside, That is why, right? So if we try to use this structured binding with the private members or the protected members, then we will get the compile time error saying that the members are not accessible outside. Correct? And then no partial binding allowed. So this is very important. So for example, we have seen the array of 2, right? 10 and 20, and this is integer, right? And we have used auto keyword here, v1, v2, right? And v3 for example, and arr, either this one or auto v1 and arr, right? So what is the issue with these two statements, right? So arr is having only 2 elements. Here we are using 3 elements, v1, v2 and v3. So this will also give the compile time error, right? Because here we have only 2 elements. Then what we bind with the v3, nothing is there. So that it will also give the error. And here we have v1 only. But arr is having the 2 elements here, 10 and 20. Right? So here also it will give the compile time error, right? So so that is what the limitation of the structure binding. So no partial binding is allowed, right? We must have to give the variables same as whatever the in the aggregate types are there, right? So here we are having 2 members, so we must have to give the 2 only here, 2 variables only. If it is having 3, then we have to give the 3 only. That is what the limitation of the structure binding. Correct? I hope this is clear. No partial binding allowed. So now do not work with bit fields in structs, right? So bit fields, I hope you know about the bit fields in structures, right? So where we can give the number of bits for particular data type, right? So that is what we can do with the structures, but that is not allowed with the structured binding, right? I think this feature is supported in C++20, not in C++17. So that is what we can see in the upcoming videos. Inherited class object cannot be decomposed. So this is also very important. In one of the interviews, it got asked, right? And the guy could not answer this one. So for this, the answer is, for example, we have a base class, right? And we have here integer, for example, x, and we have a child class, right? Public. This is publicly inherited, and we have here integer y, public, right? This is also public. So now here we cannot use the object of C for with the structure binding, right? Why? Because now this object of C becomes non-aggregate basically. Correct? So here in this case we cannot use the structure binding. But what if we have only right? So but if we have only B and here integer x and y public, right? And here we have child class of the B, nothing is there. Now we can use the structure binding object of the C, right? C obj. So this obj can be unpacked with the structure binding in this case, because C nothing, no members are there in the C, right? So this is the one case, but it simply says like inherited class object cannot be decomposed, but this is right, that is what it is mentioned here. Or vice versa, if these members are there in the child class and nothing is there in the base class, in that case also it works fine. Correct? So these are the limitations, right? I hope it is clear. Inherited class object cannot be decomposed, but some specific use cases where it works. That is what I have seen, right? Now the last is static structure binding is not supported in C++17, right? Static structure binding, right? So static keyword or extend keyword, right, cannot declare an explicit storage class. So I hope this is very simple, right? The basic principle of the C++ storage classes are like we cannot use multiple storage classes at a time, right? And auto is also a storage class, right? Auto, extern, right? Static, correct? register I think deprecated. So the yeah, so these are the storage classes. So now I have already created one video related to storage classes, so please go through that video. You will get to know each and every aspects there with examples. I have explained there with examples about the storage classes, correct? So here we are already using auto keyword here, right? We are already using auto keyword here, right? So with auto we cannot use the either this extern class or the static class, right? That cannot be used. That is what it is mentioned, cannot declare an explicit storage class, right? We have already there with the auto, that is why it is not supported, correct? I hope it is clear. It is very simple. We cannot use the static or external or any external storage classes with the structured binding. So now we can conclude our session by saying that structured binding simplifies the code, right? That is what we have seen using the multiple examples, right? We have covered the structured, what is the structured binding, the syntax of the structured binding, the structured binding by value and structured binding by reference, right? For reference we just use the ampersand, right? And then we have seen the examples of the array, std array, tuples, pair, structure, class, right? And advanced usage of the structured binding with the range based for loop, right? Structure binding by reference. We have used the structure binding in the statement of the if statement and the switch statement, and right, and we have also used with the return value from the function and the limitations, right? And so now we can say structure binding simplifies the code. It is very useful in unpacking complex data structure into the individual variables, and it enhances the readability and maintainability of the code. Thank you for watching the complete video. I hope structured binding is clear to you. Yeah, see you next time. Till then, keep learning and keep exploring.